Hello, everyone. This video is coming to you as one of the critical or important component of your week data 445, week 7, or module 4 of the course. And the primary reason this is coming as a video also in the middle of the week, and also the fact that you're not doing this hands-on is because of a very recent change that happened in the AWS lab that not just changed the component, they have updated the component in a major way, but also this component is no longer now available within the AWS Learner Lab that is designed for this course. And one of the reasons being that the new component or the updated component that we are primarily using for this tutorial has a very heavy cost. It can potentially take away almost half of your credit within a single run of this tutorial, right? You have a $50 free credit. You could potentially spend almost half of that in just a single run. And in case you have to do it, one more time or maybe a couple more times, you'll probably run out of your credit, right? So that could be one of the reasons why it is currently deprecated or no longer available in the AWS Learner Lab. But having said that, we did not want this coming to you as a disadvantage to this course or to the students of this course. And so we wanted to be a little creative in how we can put this out to you, or see that at least you would be able to see how the component, the AWS SageMaker that we're talking about, is being used to quickly create machine learning models for a given data set. We wanted to have you to then, see that exploration is not completely died, but it can, be seen here via this through this video or this demonstration. And also the fact that we could still keep the quiz, the week 7 quiz, complete for you. And this quiz not only has questions from your week 7 reading material, but it also has a lot of questions from this tutorial. So we wanted to make sure that you would, by the end of this tutorial, also have that answer sheet filled with the answers. So what I would suggest is you can pause this video for a couple minutes, make sure that you bring up the answer sheet, which has now been uploaded in your tutorial folder. So please log into your classroom, access that answer sheet that is there now available to you, along with this, when this video is posted, that sheet has also been posted. So you can now access it, open it up, and keep it handy, keep it ready, so that while we are going through the video or going through the steps within the tutorial, you will be able to note the answers in the answer sheet that is going to help you to complete your quiz. Okay. So the purpose of this tutorial is to build multiple machine learning models in an automated fashion with the use of AWS SageMaker AI. It was initially called AWS SageMaker. Now the name has changed to AWS SageMaker AI. Now, AWS SageMaker AI provides a set of solutions for the most common machine learning use cases that can be deployed readily within just a few clicks. It helps you prepare, build, train, and deploy high-quality machine learning models quickly by bringing together a broad set of capabilities purpose-built for big data machine learning. And you'll see all this, right? We'll be actually using this component to quickly build models. So for this tutorial, a sample bank data set provided by AWS and stored in a publicly accessible AWS S3 bucket will be used. So just a general architecture, or if you want to just kind of view what we are really doing here, is we are taking a publicly available data set and which is made available by Amazon, is loaded in an Amazon S3 bucket. And then it is being pulled into AWS SageMaker AI. And then you choose a target column. When you build a model, you'll pick the target column, and then you will run this on AWS SageMaker AI. Okay. So the scenario is, just to make it a little interesting as to what you're really doing, the scenario is that you work for an organization that uses Amazon Web Services, AWS, and you are given a Portuguese bank institution's marketing data set to predict whether a customer will enroll for a term deposit at a bank. In other words, the classification goal is to predict if the client will subscribe a term deposit, which is marked as, or the column is named as Y. Now, to get the most accurate machine learning model, you will use AWS SageMaker AI's autopilot feature on this data set. Now, autopilot generates each candidate model in a two-step procedure. The first step performs automated feature engineering on the data set, and the second step trains and tunes an algorithm to produce a module. Now, this tutorial will help you solve this problem. It trains different models and then selects the best model that can be used to test the prediction power of this model candidate. Now, since it's a tutorial for learning purposes, the bank marketing dataset is reduced to only 41,000 records or rows in the dataset. But the process of using autopilot to build multiple models would remain the same if there were hundreds or thousands of records representing big data or a large volume of data. So basically, we're just running a test, simulating it, seeing how, if we can do it for a few thousand or 40,000 plus records, then it should, in theory and practically, also work for many, many more records, which would come like a big data kind of a volume. Okay, for a big data volume also it should work. So here's the view of the data set, and I know it's not that legible on the screen. So let me zoom this in a bit. And so there are a few variables in this particular data set, and this is as you know, it's the bank's customers, like all the customers. Some of the customers are the past customers or the current customers of the bank who would have either accepted or bought a term deposit or not taken a term deposit, right? Not bought the term deposit from the bank. So in this particular data set, you have the customer's age, their job, what kind of a job they have, so some job description, marital status of the customer, education level, whether they're high school, illiterate, professional, or just basic education, have their account in default at any point in time, what's the average yearly balance, what's their housing loan, do they have a housing loan, do they have a personal loan, and then day of the week, before that, contact communication type, what kind of communication has been established with this customer, the day of the week, the last contact day of the week, month, the last contact month of the year, duration, what was the last contact duration, the campaign, how many times the customer has been contacted, the number of days that passed after the client was last contacted. -1 means client was never previously contacted, right? Or it shows you the number of days when it was last contacted. Then previous, which is the number of contacts performed before this campaign and for this client. The P outcome is outcome of the previous marketing campaign, whether it was a failure or not a failure. And then finally, the value of Y, or called the column Y, which is if the client did purchase or subscribe to a term deposit. Okay, so this is the data set here. So your Y is your target column. So just some special instructions again. When you watch this video in its entirety, make sure that you complete the answer sheet that is provided in the tutorial folder. As I'm hoping by now, you all have that tutorial sheet or the answer sheet in front of you, and you're going to be, taking in notes or, putting or capturing the answers, which I'm going to point out. So it's not going to be any kind of a quiz but one thing that you have to really pay attention in this video is C4 or the cues where there are answers that are required. So take a look at the answer sheet one time, just glance through it on all the required information there. And then with using that, you can then complete your online quiz, which has questions on your week 7 material and also on the quiz, on the tutorial as well. So it verifies and tests your current week's material as well as the tutorial completion. And after completing the online quiz, you may submit the answer sheet document in the big data tutorial submission area. Again, I know there's no grading there. So, when you submit it, all that grading is happening within the quiz itself. However, I will strongly encourage you to submit this answer sheet in the tutorial submission area. Okay. So with that, I'm going to dive right into the AWS console, and I'm going to stop sharing the screen and go to my AWS console here, okay? Okay, so we are now on your AWS console, as you can see. So first and foremost, and before I kind of start working on this, let me tell you that, whichever experiment, tutorial, assignment you go through, you always want to have instructions, your script in front of you so that you can go through this smoothly. I do have the list of steps or the script also handy so that in case I need to kind of take a look at or need to reference it, review it, I would be able to do that, right? Because you're not going to remember all those multiple steps and dozens of steps that you would be probably going through, right? Okay. So just a caveat there. So you'd search for, AWS SageMaker or SageMaker AI. And what you want to make sure is not use the deprecated or the old SageMaker, but the Amazon SageMaker AI. So click on Amazon SageMaker AI, and then you would be creating a domain here. The first step is creating the domain. So for this tutorial purpose, we're going to use a setup for a single user, a quick setup. Okay, so I'm going to click on that. And it has started working on it. Now this takes some time. So what I'm going to do during this entire tutorial or this video, I'll be, pausing the video here at my end. Whenever there's a step that is going to run in the background for several minutes. This tutorial actually, the entirety could take anywhere between a couple of hours to 3 hours, but I don't want you to be here for all that time, right? I want to make this video a short video for you, as short as possible, just to make sure we hit to the right points and you see all these components in play rather than just sit here and see the components being created, right? So at this point in time, the SageMaker domain is being created. So I'm going to pause the video. We'll come back when you have the domain ready, okay? Okay. back to the video, the SageMaker domain is now ready to be used. As you can see here, the message on the top of the screen. Okay, so click on the domains here. And as you can see here, the quick setup domain has been created. It is already in service. So once that is done, the first thing that you want to do is, we'll click on the notebook here, and we'll create a notebook instance, okay, that will run on this AWS SageMaker or in this particular environment. So let's call this my name, week 7 tutorial, okay? And we can keep all the other parameters configuration as is, the default, and we'll create a notebook instance. Okay, so the notebook instance is created right away, but it's still in the pending status. Again, this takes few minutes for the notebook to be operational, so we'll have to wait for a few minutes. Again, we'll come back when this notebook is ready for use. Okay, we're back, and the notebook is now in service. And as you can see here, you have the option to open Jupyter or open Jupyter Lab. We're going to choose Open Jupyter. Okay, so once the Jupyter is open, we can create a notebook here. And we'll choose the default kernel here, which is Conda Python 3. And the code that we will execute, a very simple code, but I'll still explain as we go through. And we'll take one chunk at a time. So let me take off and we'll run one chunk at a time, understand what it's doing. So this code here is what it's doing is it's as I mentioned, we're using a sample data set that's publicly available by Amazon. So all we are doing here is we're getting that zip file, we're unzipping it, we're extracting the contents of that zip file. So let's get started. Okay, well, that was very quick. As you could see here, it had a few files. It created a folder and it put in all these 3 different files in that folder. Very good. Okay, let's go to our second chunk. And okay, and this is going to be an important piece for you. So again, this is what's required in it to be filled in your answer sheet. So let's run this. It's going to ask you the last column of when you run this piece of code, like what's the last column that's displayed. So once this code is completed execution, you can take a look at which column do you see when this is completed. Okay, so here's the data that is being displayed, and you can see the last column that is displayed here. Okay, so this is the name of the last column. Hint, hint, this is required to be filled in your answer sheet. Okay, we'll move on and we'll see what is left out. Okay, so I'm going to take off this piece here and we'll keep this piece. Okay, we'll use this chunk. So what we're doing here, we did get the bank additional file, which is consisting of 41,000 records. And what we are doing is we're extracting the first 2,000 records from this file. And the reason we are doing that is we're going to use this as our test data set. So when the model is built using the 41,000, we are going to then use this 2,000 records to test this model out. Without, of course, it will take off the column Y from this data set to see what it will really come back and predict. And then we can compare with what was there in this 2000 records versus rows versus what it predicted. Okay. So let's run this chunk here. Okay, so it has already created it. Now we can move on to our next pieces here. Okay, so what this is doing is it's using SageMaker and SageMaker session, and it's going to upload this in a file into an S3 or into the SageMaker area that could be easily accessible by SageMaker. And then we are going to get the URL of it. So it's going to put it in Amazon S3 bucket and so that it will be easily accessible to SageMaker AI. So we'll run for the first file, is the entire 41,000 records of the full data set. And this takes a few seconds to complete it. And when it completes, it will give us a URL or a URI. This is a complete the path to the S3 bucket. Okay, so it completed. As you can see here, we have the bank additional full.csv that has been uploaded into an S3 bucket. Okay, now we'll do the same for the last file. And I'll just keep the same, statements here, although could have reduced a couple of them, but we'll just keep it just to see that, we just have to run this for the next file, keep the same, and then we'll get the URI of this one. Okay, that's also completed. Now we can go back to our SageMaker. So now I think whatever we needed to do in the notebook has been completed. We'll go to SageMaker. And in this case, what we'll do is we'll go to now something called as Canvas. Okay. So when you go to Canvas, it has already created a default user profile. When you created the domain, it created a default user profile. So you're going to click on this canvas. And this is where we are going to, this is the main, one of the main components of the Amazon SageMaker, which is going to be used for, pulling up your data set in Canvas and then running your machine learning models. And we'll see that in a few seconds here. Okay, so we are in the SageMaker Canvas now. And the first thing we want to do is click on datasets. And as you can see here, we have all the other sample datasets in Canvas, but we don't see our bank dataset, right? So we have pulled it in an S3 bucket as in the previous steps within the notebook. What we're going to do now is import and prepare this data set in Canvas. So we'll select a data source, which is S3, and we are going to go back to our notebook to get the path to that S3 or to that full data set, okay? I'm going to copy this file, come back to the canvas, and give this S3 endpoint, okay, this path. And then click on Go. Okay. So it got the file here. Click Next. And dataset name. Okay, we can give a good dataset name. Okay, we'll just keep it right now as is. But let's say in the import time, we will change the name of this particular dataset when we export it to Canvas. Okay, so that's created a workflow it has pulled the file. Now you can do any kind of transformation on this file before you actually have this data set exported to Canvas. So we'll do is we don't need to do any kind of transformation. We'll just export this data to Canvas data set. Here we can just give name here. So bank full set, okay? All right, data set bank full set, we just call that name. Any name you can just give it, but we'll just use it as, or you can just say bank full, okay? And export it. So this is a data flow. It's pulling the data from the S3 bucket, checking if there's any transformation to be done. In this case, we did not do any transformation. So it's just running and it's just going to pull it into Canvas. Okay, that's done. Okay, as you can see here, it's exported successfully. All right, so let's go back to the data set. We'll have to do the same process for our test data set. So as you can see here, data set bank full is now showing up in the Canvas list. We'll exactly go through the same steps and go to our notebook here. And now we'll get the URI or the S3 endpoint for our only 2000 records, okay? Okay, just copied that, coming to Canvas, and we'll click go. Okay, and then we click on next. Again, we click on import. And it just asks the same thing. Do we want to transform or just export? We'll just do an export to Canvas dataset. And this time we call it as dataset underscore bank underscore test. And we'll export it. Okay, very good. That's completed. Now, if you go back to the dataset, make sure you have both your datasets available, right? Okay, so what we'll do now is we'll choose dataset bank full. And as you can see here, once we click that, we can create a data flow, update it, or create a model. So we'll click on creating a model. And let's call this model our bank model. Or let's call it bank term deposit model. And you can just be creative with the names here, but we'll just pick some name here, bank term deposit model, and say create. And we'll have to choose. So it says select a column to predict. The column to predict is, it shows all the columns of this data set. We'll choose Y. Okay, so it's a 2-category prediction, right? Yes or no. Now we'll click on something called configure this model. So it's a 2-category model. That's fine. It's recommended. And it's only 2 categories, yes or no. Objective metric, we'll keep F1 as is. Training method and algorithms, we'll click on hyperparameter optimization. Well, when you click on that, we'll see here there's XGBoost and there's multi-layer perceptron. You can select one or the other algorithm here. Let's say I like XGBoost. Let's go with XGBoost, okay? Alternatively, we could also pick this one, but just for the sake of XGBoost, one of the popular algorithms, we'll just use that. Click on data split, sorry, it's 80-20. We'll just keep it as is, it's default. Maximum candidates or runtime, we'll keep this configuration as is. No change in there, we keep the default one. Click on save. We come back to the screen here, and now we see that this is changed from a quick build to a standard build. So we'll click on the standard build, and now it's preprocessing, or it's starting to build the model. and very shortly it's going to tell us how long it's going to take, right? Tentatively, how long would it take? And it should take in some time. And when that information comes up, again, I'll go into a pause mode and come back when the model is completed. So as you can see here, the expected build time is 1 hour 45 minutes. The reason why I said that this tutorial really takes almost 2 to 3 hours, almost, or 2.5 hours, and of which most of the time is gone to building this model. But it's going through, it's not just building one model, it's going to go through multiple models. And we'll see that, right? How many models it creates. You'll see that it creates a lot of models and then chooses the best model out of it. And that's the reason why it's taking that amount of time, right? It's not just one model and for 41,000 records, it's multiple of them. Okay, so Ken, we'll come back when I'll come back and we'll see when this model is completed. Okay, so looks like the model is ready. And before we work on this model, look at all the different performance metrics, let's take a quick peek at the answer sheet just to make sure we know what is to be captured, what is to be kept in mind before I kind of just go over all the different metrics. So let me stop sharing the screen and share the Word document. Okay, so the things that we need to kind of look for and make sure this you would be able to fill this out is what is the name of the last column displayed due to the previous code execution step. So you remember we looked at the data, looked at the column. So you need to answer what was the name of the last column. Okay. In the machine learning model is displayed, what is the accuracy? So we'll look for the accuracy. We look for the algorithm. Well, algorithm XGBoost, we know that. So that's already, you can note that it's XGBoost. And then we'll look at accuracy. We'll talk about, I'll point to the AUC. We'll look at the precision of the model. And then we'll look at the field having the maximum SHAP value. And what is okay, so that's about the model. Once we've done with the model, once we've done with the prediction, then we'll look at the accuracy, precision, recall, and F1 score of the tested of the model that's tested with 2,000 records, right? So that will come in next. After we are done with the prediction, we'll come to these 4 items here for last 4 questions in this answer sheet. But we'll be definitely talking about these, right? And then the only thing that is going to be missing, but you can still be a little creative here while you are looking at the different models and you see a list of all the different models that are created. When you go to that part of the video, you may capture the screen and paste it here. But even if you don't, that's okay. At least you can take a look at what all the different models that have been created. Okay, so I'm going to stop sharing now and start sharing the other screen. Okay. All right. Here we go. Alrighty. Okay, so let's start from the top. Look at all the different metric. So the F1 is 0.656. The accuracy is 89.949, just 89.95. It's okay, not too bad. I mean, it could have been better. Maybe we could have played with the different types of models. We could have got better than that. But anyway, this is just a trial run, 89.94 and 0.656. The field that has got the maximum SHAP value is duration, just 35.724%. So this is the field that is used, and it provides the maximum prediction for the value for the variable y for the target column. Okay. Looking at the other metrics, advanced metrics. So we looked at F1, we know accuracy. Precision is 97.93, right? So that's a good one. Precision is that of all the times that no was predicted, the prediction was correct 97.93% of all time, of the time. And recall, the model correctly predicted 90.588% to be no when Y was actually no. So that's recall is 90.588%, and the AUC is 0.95, right? So again, not bad at all, considering, when it's the positive class is no. If it is yes, the metric does go down, which is, it shows up here on the top. When the model predicts Y, the accuracy goes down a bit, because this is also that there are not too many Ys in the data set. It's kind of a little imbalanced. But in any case, the accuracy, the precision goes down. The recall is also, all these numbers do go down. The AUC still remains 0.95. Okay. So as far as what you will kind of put up as in the answer sheet will be these numbers here. F1 0.656, accuracy is 89.949, precision is 553.388, recall is 84.91, and AUC is 0.95. Okay. All right. So let's go to now, since we've captured all, oh yes, one more thing. If you want to kind of take a look at the leaderboard, right? So these are all the models that have been created. Look at all the different models. The reason why we spent a lot of time, look at this list. See how many models have been created in this time. The last an hour or so, a little more than an hour, but it created all these models to come up with the best candidate model, the best model of all these different models. So if you want to take a quick snapshot, I'm going to just freeze a little bit here, or I can just wait here for like few seconds. These are all the different 5 top models. And as you know, we chose XGBoost. So these are all XGBoost kind of models that were created, but these are all the top 5 models. So take a quick snapshot if you want to attach it to your answer sheet. If not, that's okay too. Okay. All right. So with that, we'll now proceed to, we'll go back to our model here, and we will do the prediction. We'll do the prediction of the with the 2000 records that we had put it aside. So we click on the data set. We choose the data set bank test. Remember, we are doing the test with 2000 records only. So we'll do this. We'll do the generate predictions. And we'll pick this. Oh, it's sorry, generating predictions still. Okay, so the predictions are ready. I'm going to view this. And as you can see on my screen here, so it has a prediction, and we can also download this. We will need to download this, and I'll get to the reason why. But let's download this predicted data set. And I am going to choose. Okay. Okay, the downloads. This is the predicted data set. Okay, so predicted data set, we'll close this, and we will then go to our, okay, so we got the predicted data set, and we want to now look at the notebook. And the reason why we would do that, this one here to the whole, yeah. I think we can close the other notebook that we had. So let's shut this down. We don't need this. So we'll close and shut down this notebook. And we will come here and we will open up this first 2000. This is the original, the first 2000 data set. Remember, we created it like after we got the full data set, we took out the first 2000 records, and we put it aside, and we call this as bank additional first to CSV. So we will also download this. Okay, so we will put this in the downloads and save this. Okay, so now we've got the data set, the original data set, which is right on the screen. We got the predicted data set. And what we are going to do next is find out what did we get as the precision, recall, the accuracy, F1, all those last four results that we need for how did the data, how did the model work on these 2000 records. Okay. So I'm going to freeze this at this time. Okay, we're back. All right, so what I'm sharing with you on the screen is the predicted data set. Remember, we ran the 2000 records against the model. And so what you see here is there was this Y column that it had predicted. I renamed this column as predicted.y. So this is all the predicted Y. And then at the from the original 2000 records, right there, we also did download the 2000 records file, and all the Y label, the Y column values, I kind of copied it here. So just to get it in one file. The rest of the columns of probability was also been captured from the predicted. It's from the predicted file. We leave it as is. And what we'll create a column here called outcome. So we can, all the four values that we're looking for, like the F1 value, the accuracy and precision and recall, we can also do it programmatically, but I think it would help to just kind of, just be a good refresher for how you would quickly, do that manually as well. So that's the only reason why we are doing this manually, okay? There is no reason we can definitely do this very much programmatically as well. So I'm going to get that from my script. Give me a second, the formula that we will apply here. Okay, so the formula is, let's see, it's a copy sometimes from the Word. It does not really do a good job, but let's see. Looks like it did a good job. Okay. And okay, so this is what's happening here, okay? Let me explain. So if the original value is no and the predicted value is no, then we know it's a true negative, okay? Let me bring in the other values as well and show you the outcomes. Okay, so that's the true negative, which you all know. Then what's the false positive? So the false positive here would be if the original prediction is no and the the Y value is no and the predicted value is yes, that's a false positive, right? So this is false. This did not do a good job with that. So that's false positive. Now let's look at true positive. So true positive would be when the value or the original value is yes, and the predicted value is also yes, then that's true positive. And now the false negative. The false negative would be when the original value is yes and the predicted is no, that becomes a false negative, right? So what we are going to do next is look at all the total of true positive, true positive, true negative, false positive, and false negative, right? We'll take a look at all these, the total values, total number of rows under each of these categories, and then we can put that in a formula and see what the accuracy, precision, and recall and F1 score of the prediction is of the 2000 records. Okay. Okay, let's come back. All right, back on the spreadsheet here. So I just calculated all the numbers here and also put up the formula for each of these performance measures and what's the outcome, right? So with 2000 records that we used for prediction, the true positives were 39, true negative, total of true negatives were 1907, the total of false positives were 51, and the total of false negatives were 3. And as you can see, the formula for accuracy, true positive plus true negative divided by the total of all true positive, true negatives, false positives, and false negatives would be accuracy. Precision, true positive divided by the addition of true positive and false positive. Recall is true positive divided by addition, the total of true positive and false negative. And F1 would be 2 into precision into recall divided by the addition of precision and recall. So if we do the math, if you look at all the different, put all these numbers here, the accuracy comes out to be 0.973. Again, please mark this in your answer sheet. The accuracy of the tested, the predictions of for the 2000 records, the accuracy came out to be 0.973. Precision came out to be 0.433. The recall is 0.929, and the F1 value was for the F1 measure for this one was 0.59. Okay, so with that, we got all the different values. Let's take a quick look at the answer sheet just to make sure you got all the different measures or everything that you need there. So I'm going to bring up the spreadsheet again. Bear with me for a moment. Okay, so going from the top, we got the last column that was displayed. Then the machine learning model, what's the accuracy, what's the algorithm, XGBoost, what was the AUC? We looked at that before coming into the spreadsheet. What was the precision of the best model? What was the column that had the maximum SHAP value, duration? We looked at that. Then we saw the accuracy just on the spreadsheet, looked at the accuracy and the precision of the model of when it was tested, the recall for that for the predictions, and then the F1 score when the 2000 records were tested. Okay, and if you took a screenshot, there would be a way to even include your screenshot in your answer sheet. Okay, so with that, we conclude this tutorial. Hope this was not too long, and you got an idea of what an Amazon or AWS SageMaker is and how it could be really used. And it's much more powerful. There are a lot of features that you can really make use of and build different types of model. As you just saw, that just with a very simple set and with just a very basic configuration, we were able to just build so many different models in the background within an hour. Just think that if we can use the power of SageMaker, we could take in any data set, run it for different model techniques, different algorithms, let it choose and provide you the best model. You can even just ask it to create one big best model by internally creating multiple models. So it can do all that. But in the interest of time, we just use the quick setup here and a quick test with 41,000 records. Okay, hope this was helpful. Good luck, and please do not forget to complete your answer sheet, submit it, and take the quiz. Okay, good luck. Thank you.